Quality insulation installation. The reference for these verifications will be found in the reference appendices section RA 3.5. That is the link again of where you can download the reference appendices from, and they're also available on the LMS for download. So what is quality insulation installation? It's a procedure applicable to wood and metal construction of framed and non-frame envelope assemblies. It's used for verifying the quality of insulation installation and air leakage control used in low-rise residential buildings. The overall training goal for this PowerPoint is to familiarize yourself with the quality insulation installation, protocols, equipment, and forms. And these are sections that we're going to be covering in this PowerPoint. So let's start off with the equipment specifications required for these verifications. Now you're going to be using a coring tool when taking samples of loose fill insulation in the attic. So this is used to measure pound per square foot of blown insulation. It has to be at least 18 inches in length or longer than the thickest insulation sample. A 13.54 inch inside diameter equals to 1 square foot of area. Postal scales are used to measure pounds per square foot of blown insulation. They need to be accurate within plus or minus 2 grams or plus or minus 0.004 pounds. If you're dealing with spray foam insulation, spray insulation probe are used to measure the thickness of spray foam insulation. They shall be accurate to within plus or minus 1/8 of an inch. They shall be designed and used in a manner to cause minimal damage to the insulation. So now let's talk about definitions that have to do with the quality insulation installation verification. What is a continuous air barrier? We had talked about this before in the Title 24 overview section, but let's review. A combination of interconnected materials and assemblies joined and sealed together to provide a continuous barrier to air leakage through the building envelope, separating conditioned from unconditioned space or adjoining conditioned spaces of different occupancies or uses. So basically it's a barrier that stops air movement from the inside of the house to the outside of the house and vice versa. And this is an example of what we're talking about. Also keep in mind the insulation must be in contact with the air barrier on all 6 sides, top, bottom, left, right, front, and back of the cavity. In this particular picture, you're seeing the red barrier, which is going to be the air barrier, and then the yellow barrier, and that's going to be the insulation. And as you can see, they're in full contact with one another all the way around the conditioned area of the house. So here's some examples of materials that are approved as used for a continuous air barrier. You can use plywood, minimum 3/8 of an inch, oriented strand board, minimum 3/8 of an inch, extruded polystyrene insulation board, minimum 1/2 an inch. Foil back polysaccharide insulation board, minimum 1/2 an inch, or foil back urethane foam insulation, 1 inch. Also, closed cell spray polyurethane foam with a minimum density of 2.0 PCF and a minimum thickness of 1/2 an inch, or open cell spray polyurethane foam with a minimum density of 0.04 to 1.5 PCF and a minimum thickness of 5.5 inches. All these materials can be used as a mean of a continuous air barrier. Also exterior or interior gypsum board, minimum 1/2 an inch, or cement board, minimum also 1/2 an inch. You could use a built-up roofing membrane, modified bituminous roof membrane, or full adhere single-ply roof membrane as well. Particle board, minimum 1/2 an inch, or Portland cement or sandpar or gypsum plaster, minimum 5/8 of an inch. They can also use cast in place and precast concrete, fully grouted, uninsulated, insulated concrete block masonry, or sheet steel or aluminum. So all the products that we just described can be used as a product application as a continuous air barrier if installed properly. Now, what do we mean by airtight? Airtight means limiting the passage of air either in or out of the building envelope. For these procedures, airtight shall be defined as an assembly or air barrier with all openings caulked or sealed with minimally expensive foam or taping sealing of adjoining surfaces of air barrier materials and assemblies. And on the picture on the left, you can see samples of air sealing within the actual framing assembly. Compression is the compacting of insulation in an assembly that results in elimination of air pockets trapped in the material that gives the insulation its R value per inch. Compression is very detrimental to insulation. So the more compressed the insulation is, the less effective the insulation actually is. So for example, you could have a piece of bat that's an R13 in the wall, but a compressed R13 bat might only have an R7, R5, R3 value due to the fact that it's compressed. Gaps. Uninsulated areas at the edge of insulation where insulation is not in contact with framing members or other materials at the edge of the insulation. Gaps occur when insulation length and width is too short for the cavity. So in the picture right here, you see obviously insulation does not cut properly. There's big gaps top and bottom. That's obviously bad. You want the insulation to be completely filling all of the wall cavities within the thermal boundary of the house. Voids and air spaces. Those are uninsulated space within an enclosed building assembly created where the assembly has been insulated by partial filling of the frame cavity. The partial fill results is an airspace void between the insulation surface and the assembly exterior or interior layers which form the assembly's air barrier. It's the results of compression or gaps. So every time you have compression or gaps within the insulation, you're going to result in having voids and air spaces within the actual assembly. Delaminated, that is the separation of the insulation's full thickness to facilitate its installation around or between obstructions. So in this particular case, you can see a electric wire running through the middle of the framing assembly. In this particular case, the insulation would be delaminated in half so that you would have equal insulation in front and in the back of the wiring. You do not want to compress the insulation against the wire because that's going to create a gap on the outside. Hard covers, building materials such as plywood or gypsum board, which become part of the ceiling air barrier and are airtight. So we're going to be covering hard covers later on as well, but all the building materials that we talked about earlier can be used as a mean to construct and install hard covers. Draft stops. A material device or construction installed to prevent the movement of air within open spaces of concealed areas of building components, such as crawl spaces, floor ceiling assemblies, wall assemblies, roof ceiling assemblies, and attics. So draft stops limit air movement within the actual building assemblies. Friction fit. It's a means of attaching insulation within the frame cavity without the use of mechanical fasteners, such as the material's full thickness in all directions is sufficient to maintain its installation integrity. So basically, installing insulation by friction fit basically means cutting the insulation in such a way where putting the insulation into the wall cavity will hold the insulation up on its own simply by touching the edges of the framing and the wall cavity itself. Inset stapling. It's a method of attaching face batts or blanket insulation to wood framing. The flange of the insulation facing is pushed inside the face of the framing member and stapled. Please keep in mind that, as you can see in the picture, the voids on the left and right side of the bat, which because obviously it's going to be stapled to the actual framing members, it cannot be more than 2 inches laterally. Minimally expansive foam sealing material or polyseal. It's a single component polyurethane foam system typically formulated in a handle can or a portable container to seal and fill construction gaps and crevices, holes, and cracks without distorting adjacent framing. These materials are not used for insulation purposes, rather as agents for air sealing of gaps and crevices that are too small to be insulated. Manufacturer specifies the approved use, for example, our windows, doors, etc. Net-free area. The net-free area of a vent cover is equal to the total vent opening less the interference to airflow caused by the screen or louver used for ventilation. Screen or louver vent opening covers are typically marked by the manufacturer with the net-free area. So anytime you're buying a louver or a vent of some type, the actual product specifications will tell you what the net-free area for that particular vent is. It'll be specified by the manufacturer. Now let's talk about some of the actual insulation types that you might see out in the field. The most common one that you'll see is the batten blanket. It's made of mineral fiber and mineral wool. It's used to insulate below floors, above ceilings, below roofs, and within walls. Loose fill insulation. It's loose fibers or fiber pellets that are blown into building cavities or attics using special equipment. They're usually installed in walls, floors, attics, and below roofs using a dry pack process or a moist spray technique, and may include a netting material. Now, loose fill insulation could be cellulose, which is basically shredded paper, or it could also be mineral fiber or fiberglass as well. Rigid board made from fiberglass, expanded polystyrene, EPS, extruded polystyrene, XPS, polyisonerate, or polyurethane. It can be used for above roof decks, exterior walls, cathedral ceilings, basement walls, and as perimeter insulation at concrete slab edges. Spray polyurethane insulation, or SFP. A two-component reactive system makes that a spray gun or a single-component system that cures by exposure to humidity. The liquid is sprayed through a nozzle into walls, roof ceiling, and floor cavities. Structurally insulated panels, or SIPs. It's a composite building material consisting of an insulating layer of rigid polymer foam sandwiched between two layers of structural board. They can be used for many different applications such as exterior walls, roofs, floors, and foundation systems. Insulated concrete forms, or ICFs. They're interlocking modular units that can be dry stacked without mortar and filled with concrete as a single concrete masonry unit. They lock together externally and have internal metal or plastic ties to hold the outer layers together of insulation to create a concrete form for the structural walls, roof ceilings, or floors of a building.